All right, let's finish up section 5.3. I promised you for a while it would talk about when we have to use point-slope form and when we're going to use slope-intercept form. So the first thing I'm going to do is remind you that y minus y sub 1 equals m times x minus x sub 1 is point-slope form. We aren't going to get a choice sometimes, and it's going to be very obvious. Like the directions are going to say, write the equation in point-slope form. When that happens, then you get to stop sooner than you would in previous problems. So if they told me that for example, my slope was 6, and I went through the point 4, 5, and my direction said write the equation in point-slope form for a line with a slope of 6 through the point 4, 5. We would just simply write y minus the y value is equal to the slope times x minus the x value, and stop. What happens is that we end up with one line starting to have many different versions, and that's what point slope is good for, that we could have one line with a lot of different versions of it instead of just the one for slope-intercept form. So first part is that we have to read our directions carefully. The second is that our point-slope form is great for graphing, especially when our line does not go through the y-axis, especially when the line does not go through the y-axis. Take, for example, the line that looks like this. I've put in this point at -5, -1. I'm putting in a point at -4, 2. I'm putting in a point at -3, 5. And hopefully you used a straight edge because you don't want any wiggle worms like I have. I've put in those 3 points, and you'll notice that this picture does not go through the y-axis. But you'll also notice that if I had bigger graph paper, it would go through the y-axis. When we look at these problems, when we do this, we're going to use the fact that our slope is, we count our rise and our run, or rise over right. So in this case, that's rise 3 every time I moved right 1. So my slope is 3. And we have quite a few points that we could in fact use. We could use, and actually I'm going to write this the same way I did in my notes. I wrote points we could use. And we could use the point, like I labeled them, -5, -1, -4, 2. And we could use the point -3, 5. We have to use the same slope because all of those points are on this line that has a slope of 3. But my point-slope form has 3 different versions for these 3 different points. Using that first point, we would have y minus -1 equals 3 times x minus -5. And we know that minus negatives become plus positives. So on a test, I would expect you to write y plus 1 equals 3x plus 5. We could also write that exact same line using the next point. Y minus 2 equals 3 times x minus negative 4. And if I clean it up, on the test I would expect you to write y minus 2 equals 3 times x plus 4. And again, another way to write this exact same line using this third point, y minus 5 equals 3 times x minus negative 3. And if I clean it up, y minus 5 equals 3 times x plus 3. Alright, so down below there are a bunch of problems for you to work on, and I have all the answers up, but I really want you to give them a try because they're not hard, and I do want to go over one of the graphing problems. So go ahead and pause, see what you can get done, and then come back for the graphing explanation. I mean it, pause it. Alright, let's talk about this graphing problem because they're a little bit awkward at times. The first thing you want to do when you approach a graphing problem is to identify your slope and identify the point that it goes through. We would expect that a graph like this may or may not go through the y-axis at a pretty point. Most of the time it won't, but in this case, in this first problem, it did. So we pulled out the fact that the m is equal to 3 and the x value, right, x minus the x, so we have a positive 1, and y minus a negative 2 to get positive 2. So negative 2 is the y value. We're going to plot this point, and we're going to move through our slope, the same as what we did in chapter 4. So it's just a little bit different because of where we're going to start. We do not have slope-intercept form, so we are not starting at the y-axis. So we start at the point 1, negative 2, and then we rise 3 every time we move right 1. Rise 3, right 1, 3, 1. Connect your dots with a straight line instead of a wiggle worm like I have. And I really do want you to try problem D. So give it a try. Pause it, try it. How did you do? These aren't intended to be hard problems. They should be nice and quick and easy ones. I will see you in class.